So hello, everyone. My name is Laura Montes. I'm a postdoc in the Hubert Curien Laboratory. And today I would like to start with this microgel presentation. It is the functionalization of metallic surfaces by micro-nanostructuration, employing different sol-gel processes. In this project, we are working with Montes lab in Lyon. We are working with Erase, with the Saint-Étienne company, and with Manutech. So the main objective of this microgel project is to be able to enhance and change the surface's properties. These properties could be related with optical properties like anti-reflection, appearance. You can change to the physical chemicals such as wettability, and we want to study a little bit the biological usage. In this case, we want to enhance the molecular datation and to study the biocompatibility. So we have decided to use these metallic surfaces because, as you know, the metal service life of this kind of surface is short. So we would like to enhance the catalytic performance and to take advantage the surface contact area of these surfaces. In short, we want to do change in the surface's properties. How we can do this micro-nanostructuration in metallic surfaces? Everyone knows that you can find two big groups. It is the top-down technique. Here, the researchers are growing the material from the top to the down. And here you can find etching like physical, chemical, laser ablation, lithography, and you can fine-tune these bottom-up techniques. In this case, researchers are studying the growing of this material from the bottom to the up. And here we will be focused in these sol-gel methods. Why sol-gel method? In this case, we are going to use this sol-gel methodology because in this kind of methodology, you are able to cover big area. You can try to ensure that you don't have any dust or contamination. You don't need to use flat substrates. You can use different shape, and you are not using vacuum. So our main proposal is to deposit a sol-gel thin film on the top of the metallic surfaces, then do micro-nanostructuration to get the final application. When you are doing this micro-nanostructuration, you are able to take new advantage, for example, corrosion protection or electrical insulation for this kind of substrates. But we should think that we have a pure adhesion between the metallic surfaces and the sol-gel. To understand this pure adhesion that we have between these metallic surfaces and the sol-gel, we should think in chemistry. In the metallic surfaces, we have this metallic bond, and in sol-gel coating, normally we have this covalent bond. So we should study the chemical affinity that you can find between both in order to know what is happening in this interface. In the literature, there is a few articles that they are speaking about this micro-nanostructuration, but not in metallic surfaces. They are studying it in glass or silicon substrate. So here, these people doesn't have this problem related with this covalent bond. People who is working with metallic surfaces, they are using another kind of techniques, and they are not doing a lot of nanostructuration. So here on the right, you can see that in the literature, the people who is working with this micro-nanostructuration in metallic surfaces are using, for example, the activation of the hydroxyl group in metallic surfaces or the oxygen-silicon chemistry to enhance this adhesion. So the objectives of this microgel project are study the adhesion mechanism between the material and the sol-gel coating, develop a hybrid braid sol-gel processes route that provides adhesion that is able to resist different mechanical tests without the scratching or the lamination, and to be able to show that it's possible to create micro and nanostructured multifunctional surface on metallic part, depositing and structuring this sol-gel coating. As I told you in the beginning, we are not working alone. We are working with different partners, such as Montes lab in Lyon. Montes lab is working in the characterization of the morphology or texturization of this sol-gel coating. We are using different microscopy, such as scanning electron microscopy or transmission electron microscopy, to study the morphology and to be able to understand the adhesion mechanism. We are working with Saint-Étienne company to develop organic and polymeric coating in order to combine it with our inorganic sol-gel coating in our lab. We will work with Manutech for the weightability and tribologic study. And here we are doing use of this focus IOV to prepare the lamella of the different sample. We are working with HEF group from IRA to prepare the sample, cut the sample, and do the mechanical test. So our starting point in this project is these metallic surfaces. It is acrylic steel with a polymirror treatment in order to have the first roughness of adhesion to enhance these properties. We are using different soil methodology. In our case, we are using TO2 and CO2 because it is available in our lab. And with the different condition for the soil, we are depositing this soil coating in the metallic surfaces. Once you have this soil coating in your metallic surfaces, the next step is to start to do this mechanical test. In collaboration with IRES, we are doing calotes. Calote is a kind of mechanical test where you can measure the thickness of the soil coating, this metallic part. We are using this ball, and with the mark that this ball presents in our soil, we are able to measure the diameter to know which is our thickness, and we can see the abrasive behavior of this mechanical test. We are using two-row well indentation with 150 kilograms to measure the hardness that you can find in this soil coating and in this soil coating and metallic substrate, and we can see the mechanical response. So in the next slide, I would like to show you the preliminary results about this mechanical test. I cannot speak about the specific soil and the specific condition because we are working with companies and we want to patent it, but I would like to show you that when you are using this soil 1, condition 1 directly on the steel surfaces with any strategy, you can see in this scratch test a lot of delamination in the soil coatings, and you can see the same in this rowel indentation, a lot of radial fissure close to this area, so it means that it is not a good result. When you are using soil 2 condition 1, again on these steel surfaces, you can see that our soil coating is totally removed. It means that this grease color is the steel. We remove totally this soil coating, and for this calo test, you cannot see nothing because we don't have a defined mark showing that we have different thickness between the metallic substrate and the soil. And for the soil 3, the same, the lamination close to this area and a no good defined calo test. So it means that after these bad results, when you are using this soil directly on the metallic surfaces in this project, we should think in different strategy to enhance it. The first strategy is to be able to activate the hydroxyl group on metallic surfaces. So with this hydroxyl group, you are able to create new bonding with the soil coating, covalent bond, in order to enhance this adhesion. When you are using this strategy in soil 1, condition 1, for example, it is not working. You can check here that the soil is delaminating in the rowel indentation, and for the scratch test is the bad results too. However, employing this strategy in soil 2, condition 1, you have good results for the rowel indentation. Here you can see a small fissure close to the area, but it is normal because we are using a lot of heavy. And here you are able to find a good defined calo test to be able to measure the coating. And good result for the soil 3, condition 2, the normal fissure close to this area, but you cannot see any delamination in the soil. I would like to say that we should study for each soil and each condition how this strategy is working with all of them. Another strategy that we are developing in this project is an intermediate layer. This intermediate layer is between these metallic surfaces at this soil. This intermediate layer could be related with TO2, CO2, diamond-like carbon layers, and these intermediate layers are characterized because they present a high adhesion on the metals and because they have the capability to create covalent bond between these metallic surfaces and the soil. When you are using this strategy in the different conditions, such as soil 1, condition 1, you can see good results for this rowel indentation. You can see a good defined calo test. In the soil condition 1, a little bit of radial fissure close to the area, but you can see a homogeneous and continuity in the soil. And here you can see the normal radial damage for this kind of experiment, and good result for the soil 3, condition 2, again, as you can check. So to be able to follow all of these results that we are obtaining in this project, we present a characterization test matrix. We are doing chemical characterization, for example, scanning electron microscopy to follow the global view about the morphology, the texturization of the samples. We are using EDX to identify the chemical element that we have on the top and in the interface layer. We are using Raman spectroscopy because we are working with CO2, so we should know which is the crystallinity of our soil gel coating related with the hardness. Thermal ground zinc incident X-ray diffraction to know what is happening with the temperature and with the peaks of the CO2. Focus IUV beam because we should prepare lamella for this sample to follow which is the behavior, and transmission electron microscopy to know it with a high resolution. The last step that we would like to have in this project is that one, you are able to define the good adhesion between the metallic surfaces and soil gel, is do this micro-nanostructuration in this soil gel coating. With this micro-nanostructuration, we are able to get the final application, for example, changing the wettability, study the biocompatibility, anti-reflective optical property. So with this project, we are able to develop rapid method that can be adapted and cover big areas and with the different shape in the substrates. So the conclusion that we are obtaining after this preliminary result is that we should define the best strategy to achieve good adhesion between the metallic substrate and the soil gel, activation of hydroxyl group, develop intermediate layer, test different kind of intermediate layer, study the behavior of this developed soil gel under the mechanical response, and once this choice had been defining, be able to prepare this functionalization study once you are able to select this soil gel under the optimal condition of this mechanical response. So it is all for my part. Thank you for your attention.
Thank you for your presentation. Is there any question on the presentation by Laura? Okay. Okay, cool. Sorry, I had to go out and back again. We were missing one speaker. Maybe I missed the part where you were discussing about the application. So the Envision applications are, could you tell us a bit more about it?
Yes, you are speaking about the final application.
Indeed,
yes,
yeah, exactly.
The idea is that to get new application for the metallic surfaces, more or less corrosion properties, change the wettability, have this biocompatibility results. But it's true that the first part of the project, that is the point that we are right now, is to define the good adhesion. And then our idea is with this laser pattern, with this lithography, change the wettability to be able, for example, to have new approach about oniphobicity, superhydrophobic behavior, study maybe see the different bacterial. It is the final part. But our idea is to have this biocompatibility properties, wettability, and maybe changing the optical and in the appearance. So it is the reason why we are using, for example, biocompatible elements like TO2 or CO2.
Okay, so the idea is to go for
yes.
Medical applications or...
Yes, and this corrosion protection too with this layer.
Okay, okay, thank you very much. Any other curiosity or... Yes, please.
Thank you. Thank you for your presentation. So for the application, you mentioned appearance. So what do you mean by appearance? Is it like matte gloss control or more color control? Or?
Yes, we can, because in this, where I'm speaking about soil gel and the condition, in this condition, it is related with the annealings. So for example, in our lab, we have the possibility to use a RTA. It is a rapid thermal annealing. And in this case, we can use, for example, ammonia atmosphere. So we can play a little bit with the color of these metallic surfaces to have this decorative and mirror termination of these samples.
Okay, so there are interference colors.
Yes,
Yeah, okay.
interference.
Okay,
Yes.
thank you.
Thank you. Now that I'm here, any other question here? Okay, good. Okay, well, thank you very much, Laura, and good luck for the rest of the project. Okay, let's thank again the speaker. You can put it on.